Form 5 Mathematics, Section 7.3, Part 3. Section C. In these sections, we will learn how to find the equations of tangents to a circle. And here we will consider two cases. The first case, if you are given the points of contact of the tangent to the circle, say the point of contact is A with coordinates x1, y1, and you have the equations of circle C in general form, then you can find the center as HK by using D over negative 2 and E over negative 2. And here, actually, it is not difficult to find the equations of tangents because tangent is just a straight line. So try to recall what you have learned in Form 4 about the equations of straight line. If you can find the slope or find the points, then you can find the equations of the straight line or the tangent. So here, for this case, if you want to find the equation of the tangent L, try to find some information about the straight line. Here, what we have are the coordinates of A and the coordinates of the center S. So first, we can find the slope of AS. And then we can also find the slope of the tangent because we have tangent perpendicular to radius. So the two straight line L and the radius AS are perpendicular to each other. So you can find the slope of tangent after finding the slope of the radius AS. You can use the product of the slope is equal to negative 1 to find the slope of L. And after you have the slope of the straight line L and you also have the coordinates of A, then you can find the equation of tangent L by point slope form. Let's study one example, quick practice 7.14. Here you are given the circle S with the equation in general form so that you can find the center and the radius from these equations. And you are given the coordinates of a point A to negative 1. And you don't know where this point is, but for part A, you are asked to show that A lies on the circle S. To show that a point lies on a straight line or a circle, you have to check if the coordinates satisfy the equations. So here, we just substitute the coordinates of A into equation of S and check if the values of the left-hand side is equal to that of the right-hand side. So for part A, we just substitute the point A into the equation of circle. So here, for the left-hand side, we have x squared plus y squared plus 2x minus 2y minus 11. You just press your calculator and you will find this is equal to 0, and which is equal to the right-hand side. So you can conclude A lies on the circle S. For part B, you are asked to find the equation of tangent to circle at A. Okay, we just try to mark a point on the circle. Say this is the point A. And you have to find the equation of tangent to the circle at this point. That means A is the point of contact. So we have the straight line passing through A. And you have to find the equation of this tangent. So by using what we have learned for this case, first, we try to find the coordinates of the center, d over -2, e over -2. So you got this is -1, 1. And we have the points A already. So here, if we let C be the center, then we can find the slope of the radius AC. You have the center, C is -1, 1. So here you have the slope of AC is 1 minus -1 over -1 minus 2. So this is -2 over 3. And second, because the radius AC is perpendicular to the tangent perpendicular to radius. So we have the slope of tangent is the -1 reciprocal of the slope of AC. So you got the slope of the tangent is 3 over 2. And finally, you can write the equations of tangent to S at A is by using point slope form, y minus -1 over x minus 2. You got the slope is 3 over 2. And try to simplify. You will get 3x minus 2y minus 8 equals 0. This is the answer. Case 2. If you want to find the equations of tangent to a circle, but the points of contact is not given. Instead, you have some information about the tangent L. Say, if you have the slope or the y-intercept of the tangents, then you can still find the equation of tangent by setting up the equations of tangent or letting the equation of tangent be y equal mx plus c. So for this case, there are two unknown constants, m or c. Depends on which values you have, then you can try to find the unknown constant m or c by given information in the questions. Let's take example 8 to learn how to use case 2. Here, you are asked to find the equations of tangent to the circle C1 with slope 3. So we just let y equal m, that means 3x plus c, be the equations of tangents. Here, you have to find the unknown constant c. So, by what we have learned about the relationship between a tangent and a circle from section 7.3b, we know that when we put the equations of the tangent of the straight line into the equations of the circle C1, they have only one intersecting point. So we have x squared plus 3x plus c whole square equals 90. and you try to simplify and expand. You will have a quadratic equation in X. So here, because there is only one intersection between the tangent and the circle. So the discriminant of these equations is equal to 0. So we have b squared minus 4ac equals 0. Then you have 6c whole square minus 4 times a times c. You got this is equal to 0. And then you try to simplify. And then you can find c squared equals 900. That means c is equal to positive or negative square root 900, which is plus or minus 30. So for this case, there are two possible values of c. And so there are two possible equations of tangent with slope 3 for this circle C1. Finally, we can write the answer. The equations of the tangents are, we have y equal 3x plus 30, or y equal 3x minus 30. Let's study one more example. Here, you are asked to find the equations of tangents to the circle again. This time, it is the circle C with the equations in general form. But here, you are given different information about the tangent. For this tangent, you have the y-intercept equals 4. So for this case, we let y equal mx plus 4 be the equations of the tangents. And this time, the unknown constant that we need to find is m. Similarly, we put the equations of tangents into the equations of circle C. And here we have x squared plus y squared plus 2y minus 4 equals 0. Then you try to expand and simplify it. Grouping the like terms, you will have 1 plus m squared x squared plus 10mx and then plus 20 equals 0. We have the like terms, constant term. For these quadratic equations, because the tangents and the circle have only one intersecting point, so we have the discriminant is equal to 0. So we have b squared minus 4ac equals 0. We have b is 10m and a, and this is c. Try to simplify the equations. And then you will have m squared equals 4. So m equals plus or minus square root 4. That means m is equal to plus or negative 2. Here, still, we have two possible values for m. And then we have two possible equations of tangents. They are y equal 2x plus 4 with slope equals to 2, or y equals negative 2x plus 4. So we have found the unknown constant m for these equations of tangent. 好，而家輪到你哋做數啦。請你做 classwork quick practice 7.15同16。咁你停咗個 video 試下做呢兩條數。好啦，咁我哋睇 quick practice 7.15先。咁喺度呢，要揾 tangents 嘅 equations to circle S 啦，而佢俾你嘅資料呢，就係 parallel to straight line L。咁講得平衡，咁我哋就用翻 slope 相等啦。咁 L 嘅 slope 呢就3，所以喺呢條數嘅 key 呢，就係你叻咗個 equation of tangents 呢，做 y 等於 3x 加 c， 跟住嘗試去揾個 constant c， 都係將直線嘅式代入圓嘅式，去睇翻個 quadratic equation 嘅 discriminant 等於0，嚟到去 solve。咁你就會揾到兩個 c 嘅 possible values， 就會揾到個 equation of tangents 都係有兩個 answer 嘅。好啦，到 7.16 啦。咁呢條數呢，你就要揾 equation of tangents to the circle 啦，而係 from 一個 point 01。咁我哋頭先睇嘅情況呢，就係如果我哋知道個 slope 或者 y-intercept， 我哋就可以去揾個 equation of tangent 啦。咁而家 from 一個 point 呢，我哋有啲咩方法做呢？其實你都可以叻翻個 equations， 用呢兩個 points 嚟到去叻嘅。咁不過如果你細心啲再去諗下01有咩特別呢？其實呢01呢就即係話呢個 tangents 嘅 y-intercept 呢係等於1，所以其實你都係叻翻 y 等於 mx 加1嚟到去 be the equation of tangents， 跟住你就會揾到 m 兩個 answer， 亦都揾到個 tangents 有兩個 possible 嘅 equations。好，咁喺講 past paper 之前呢，就同大家有一個短嘅 summary。喺 7.3c 呢度呢，我哋學點樣去揾 equation of tangents to a circle。咁有兩個 case 嘅。第一呢，就係我哋如果已知個 points of contact 嘅坐標，我哋就可以利用翻個 tangent perpendicular to radius 揾埋個 circle 嘅 centre 嘅坐標。咁你揾到 radius 嘅 slope，就揾到條 tangent 嘅 slope。咁用 point slope form 呢，你就會去揾到個 equation of tangent 咋。第二個 case 呢，就係如果你唔知個 point of contact， 而你有個 tangent 嘅 slope 或者 y-intercept 嘅，你都可以透過 y 等於 mx 加 c be 個 equation of tangents 嚟到去揾個 tangents 嘅方程。咁其實呢，頭先同你哋睇嘅 example， 你哋有冇留意到呢？有啲咩特別呢？就係好多時呢 c 同埋 m 呢都會有兩個 possible values 嘅。其實呢，幅圖會係點呢？就係以下兩幅圖啦。如果嗰條數係俾咗 tangent 嘅 slope 嚟嘅，係啦，就 given 個 slope 嘅。咁呢，其實呢就有兩條可能嘅 tangents 畫到喺呢個 circle 度，佢哋嘅 slope 呢都係 m 嘅。而第二種情況呢，就係 given 個 y-intercept of tangents 就係同一點。咁喺呢個 case 呢，其實亦都有兩條 tangents 可以係同一個 y-intercept 畫到喺呢個 circle 度嘅。咁呢個就 其實係我哋之前學 Chapter 2嘅 case 啦，就係 tangent from an external point， 咁係會有2個 possible tangents 嘅。咁喺呢度呢，就請你做 daily exercise。咁呢啲 level 1嘅題目呢，就一定做到㗎啦，就7.3C 同埋第20題。而24、25題呢，就貼近 DSE 或者會考嘅題型。咁你可以試下自己做，或者聽我講解埋2條 past paper， 跟住先去再做。咁呢2題呢，其實都會牽涉到呢，就係 deductive geometry， 即係 Chapter 1、2 circle 嗰啲嘅 properties 啦，再加埋 Chapter 7， 即係而家學緊嘅一啲 coordinate geometry 嘅東西。